Hello friends, today let's solve palindrome partitioning problem. Give a string S, partition S, such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. You should notice the keyword return all possible. Usually, we have to use backtrack to solve this kind of problems. So this is a hint. Then let's see the example. If the given input is AAB, we will get these two possible palindrome partitioning. It's just like we cut here, so we get two substring and both of them are palindrome, or we cut here and here, so the three substring are all palindrome. So we return this list. So how to solve it? Well, when it comes to a palindrome problem, we usually need to write a is palindrome function. And usually it has three parameters, which is the string and the integer low and integer high. These two are pointers. So if the char at the low index not equal to the char at the high index, we just return false. Otherwise, we move low forward and move high backward and keep a compare. So the time complexity is big O(n). Well, this is the palindrome. And now we need to partition this string. So we obviously we need to iterate the whole string. So if all the string we occur are all palindromes, and when we reach the end of the string, we know we finished the task. The list we get is a possible partitioning. So we add that list to our final result list. So this is kind of a base case. If we no string left, no string needed to process, we finish. Now let's see the main function to solve this question. We call it a help function. Why? Because you will see a recursive pattern here. The parameters we need to add, one is the result list, the final list. The current list is till current place the palindromes we added, and S is the string, and the starting index is, as I said before, current list added the palindromes we meet till now. So starting index is the rest part. Like if the starting index is 2, that means the left part are all added into the current list. The rest we need to process is from the starting index to the end of the string. So this is the function. Okay. So as we already have a starting index, we just need the right index, right? We call it high. The high, its range is the low. Low is the starting index, and the s.length. If it's a palindrome, the substring now is a palindrome, then we add the current substring to the current list, and we keep processing the rest part. So result current list and s, and this is the high plus 1, because the left part has already been processed. So we just need to handle the right part. And if the high, well, for example, if this A is a palindrome, like the starting index is 0 and the high is 0, and the S00 is a palindrome, so we add the current substring, which is the A, to the current list. Then we call it this function again. The high is 1. We need to process the rest part. And here we go again. this time high is started from 1, and S11 is still a palindrome, so we add this A to the current list. Then we call it again, right? So we get this B. And this AAB is a result. Then we return to the previous call. We remove the current list size -1, which means we remove this B. And as this high has no other possible choice, so we keep return to the previous call. So then we will remove this A. And we will see this time this high can go to 2. Because previously we choose this high equal to 1, then we can, this is a for loop. So when we return from the previous call, we can go to the next possible value. That's the that's the cases when we call this when we run this statement. When we return from the previous call. Okay, this is the recursive case. And base case we mentioned before, just when the starting index equal to s.length, we return. So how about the time complexity? We need to check whether it is a palindrome. The time complexity is linear, so it's obvious it's big O n. And as this palindrome partitioning is just like we cut for every center of 2 characters, we can either cut it here or not cut it from here. So in total we have 2 to the power of n minus 1 because the length is n. So we have n minus 1 centers. So in total is 2 to the power of n minus 1, which is big O 2 to the power of n. And in total we use this times this n. So in total is big O n times 2 to the n. Okay. So now let's write the code. We need the result array list and do a simple check if s.length equal to 0, just return result. Otherwise, call the help function result. We also need a current list and the start index is 0, and we return result. Void help function. We need the list string result list string. We call it current list. And we also need a string, and that is low. So the base case if low equal to s.length, we know we have get a valid list, so we add this cur to the result. But we cannot just pass this cur because in Java it passed by value, so it passed the address of this list. If we just add this cur, when the cur is updated in the future, it will also be updated. So we just copy the current value to a new array list, and we return. Then high from low, high less than, we get n is s.length, n high plus plus. So if it's palindrome, s low high is a palindrome, so we add the substring, which is from the low high plus 1. As substring, the high is exclusive, and then we handle the rest part is cur string high plus 1. If we backtrack, we remove the last substring, and we also need to write is palindrome s low high. So while low less or equals than high, once they are not equal, we just return false. Otherwise, low plus plus, high minus minus, we return true. Okay. Oh, sorry, missed a comment. Substring as low. No super method. Currently, the list of string. Substring as substring low high plus 1 is low high plus 1. Is there anything wrong? Substring s. Sorry. Substring, we just need to pass 2 parameters. Sorry for the mistakes. Okay, sure. Thank you for watching. See you next time.